Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. Tracing LLM inference with Phoenix. Part 1. Tracing the calls to the LLMs. Why Phoenix and how DSPY is linked with Phoenix. Recently, I had an opportunity to develop F1 score metric in DSPY for a company called Simply Discover. This company uses AI, large language models, to detect fraud in various domains. And this company wanted me to develop the metric, and during that time, I realized that tracing the calls to the LLMs are very, very important. Because in case of the DSPY metric, you can actually call the trace variable or the parameter inside the metric function, and you can look at the calls that it is made to the API, that is OpenAI API. Not just that, once I started developing the metric, I realized that there is going to be a lot of iterations going to happen, and when these iterations are happening, there should be a way that you can keep track of the modifications that is occurring, and that's when I realized tracing is important. And as I was diving into DSPY from a long time, I knew that there are ways to use servers that can collect these traces and keep it for later analysis. So that's where Phoenix actually came into picture. Phoenix provides a robust and a portable way of looking inside the modules and metrics. Second, it can actually trace the multiple calls to different APIs during the development and deployment. And finally, it helps, as I told you, in prompt optimization, in developing metrics, as well as developing modules. You'll be seeing the examples, and I'll be showing a couple of examples in this series of discussions, which is part of the DSPY playlist that I already have. And one more important point is the reason why I'm making this video is after I created a persistent Phoenix server, I felt that it's important to share it with the community. Let's actually dive in. What to expect in this discussion. So I'll be diving into OpenTelemetry and a bit about where Phoenix fits in and how the DSP instrumentation happens. And in the next video, I'll be diving into metric development, executing the evaluation, and making data sets and keeping it in DSPY. So all these things we'll be discussing in 2 or 3 videos. What's OpenTelemetry? OpenTelemetry is a mechanism or a specification that makes the system observable by instrumenting the application code. Okay, that's a lot of theory. What it really means is that if you want to understand a system from the outside, so for an example, you have the DSPY module and you want to understand what the DSPY module is doing or the program is doing, then you can instrument that program and understand it from the outside without actually looking at the code. So that's the important part, without actually looking at the code. And where OpenInference comes in, OpenInference is a complementary to OpenTelemetry. It's kind of a subset to OpenTelemetry specification for tracing AI applications. So these are already existing specifications that is out there that has been developed for making the lives of the developers as well as the deployment teams easier. Okay, now what is telemetry to begin with, or what is OpenTelemetry to begin with? So OpenTelemetry is a process of collecting, processing, and exporting logs, traces, and spans. So this is what we are talking about: collecting, processing, and exporting spans, traces, and logs. So that is all about OpenTelemetry. Now let us actually move into the parts of telemetry. Before we move into parts of OpenTelemetry, I want to talk about the parts of telemetry process itself. So telemetry is everywhere. You must have come across telemetry if you have seen about the geographic sensors that is all across the globe to foresee some kind of a natural calamity. We have been putting sensors all across the earth to get the weather details, and we are doing it to get earthquake and tsunami highlights, right? So similar to that, we can actually keep sensor in our code and actually trace how the code is working. So that's telemetry. To give a visual understanding, when it comes to the parts of it, traces are the records that actually records the path a particular request has taken. So whenever you are going to create a application, it could be a front end, it could be a back end, or it could be an application that is running in your operating system. It's going to make some or the other request to a database, to a outside endpoint like OpenAI or Olama, whatever endpoints you are talking about, and this call to that particular endpoint is traced, and what call was made, what was the information inside the call, when, where it was made, etc. Everything is stored inside this trace. Logs are just a time-stamped messages. If you have been into development, I am pretty sure that you would have been printing all your logs in the beginning, and then later you would have come across some kind of a logging package. Then you would have started logging your messages to a particular interface. So logs are pretty important, but they are not sufficient. You need to have a structured log. So that's where spans come in. Spans in telemetry is a unit of work. So if you're going to call to a particular API, so why will you call to that API? You want something to be done, right? So if you're going to call to OpenAI API, you want your request, that is the sentence that you're sending to OpenAI API, to be completed using the OpenAI model. So that's the work that you want to do, and that is represented by the span. So these spans are going to make the traces, so that it will be multiple spans, and that's how the traces are made. And for actually connecting these spans, the baggage or the context comes in. So every span has some kind of a link to the next span. So the context is continuously transferred between multiple spans. So this becomes the trace. This will all make sense once you look at an example that is going to be shown in a couple of minutes. And finally, we have the metrics. So yeah, as I already told, the reason why I'm actually discussing about Phoenix here is first of all, for the metrics that you can log, and also you can keep it for future analysis. So Phoenix makes it really easy. There are other endpoints, backend servers also available, like Jaeger, and also you have Prometheus. But Phoenix, I felt it's straightforward, and it does the job that we developers who are actually diving into AI very, very easy. Sorry about that. Now comes the OpenTelemetry parts. So OpenTelemetry is made of set of parts. So OpenTelemetry requires instrumentation of the package or the application. After that, it needs an exporter from the application to the collector. So Phoenix is a collector. It's a server that collects the spans, traces, and the logs. So it's a collector. But apart from that, we need an exporter and the instrumenter, which is going to be inside the application that you're developing. So application, in our case, in my case, it was the metric that I developed, and I had to trace that metric, what it was doing, and what calls it was making, and how it was improving. So that was the point. And then all this happens over the OTLP protocol. OpenTelemetry, first of all, was created or instrumented to begin with for logging all this stuff, the traces, spans, logs, etc. But for that, they needed to have a framework. Without the framework, they cannot create a protocol. Okay, all these things are at the design level of a particular technology. So if you guys have any questions on OTLP, you can comment it out, and I will give you the resources. But I would it's actually not necessary for what you're going to do. So let's move forward, and let's dive into Phoenix. So Phoenix is developed by Arise AI, and they have open sourced this particular Phoenix code, and you can get to look at the code here. So the link will be shared in the description, so you can take a look at it. You can use the docs of Phoenix to understand a lot about this. Excuse me. You can look at the Phoenix server, and this Phoenix server has both front end and back end, and the back end is mainly written using Fast API, and the front end has TypeScript and various other JavaScript and TypeScript related packages. I'm not going to dive into that. Our interest is to see how we are going to install and start working with Phoenix server. To do Phoenix, to get the Phoenix server starting, we need to do a pip install of Arise Phoenix. So this pulls in a lot of dependencies that is required for OpenTelemetry also. So you don't need to install the dependencies separately. And before we dive in, there are a couple of ways you can actually get the Phoenix server up and running. So there is the notebook method, where you can use Jupyter notebooks itself to get the Phoenix server up and running in a very simple fashion. And the second is using Docker containers and Docker images. So Arrays actually has a couple of Docker images available out there, which you can pull, and the docs of Arrays Phoenix actually provides you the process. The third is using the command line, which I'll be using. You can use your own command line tool that is available with you. So you can just use the this bash or shell environment, and you can get the Phoenix server set up in your local machine. Why I prefer local machine is, first thing is that you can learn a little more about how the server is getting implemented, and second is you will actually set it up with your own control. So these are the main reasons why I chose the command line option. And second thing is, you will not have an additional load of having Docker running. Third, in case of notebooks, I felt even in case of notebooks, there is a challenge of having the persistence of the data that you are logging. Yeah, there is a way you can actually have persistence through the notebooks also, just by having the proper environmental variable exported. But using a proper command line to start the server, kill the server is more clear to us what's happening. So that's the reason why I chose this option, chose this route. So let's move forward. So you have to install Arise Phoenix, and then you need to install psychopg2 binary and async-pg. So this is required. This is by default installed in the dev line of Arise Phoenix package, but you have to install it manually. And then you need to export the Phoenix SQL database URL in your environmental variables. So what I mean by this is, if I go back here, and if I say print env, so this is a way to get the environmental variable inside the bash or shell environment, and you can see that the entire link of the database is visible to us here. So we need to set up this environmental variable in your local environment. So how to do this? In case of shell environment, I usually use Linux. So it's actually much more easier to set up a lot of stuff in Linux compared to Windows, especially when it comes to databases, servers, and connecting to them. It gives you much more better control. So in case of Linux, I need to make this export happen in my bash rc, .bash rc in my local account, and then I use this alias for Phoenix, so where I actually use this command. So I use a no-hub command so that I can log the output to the Phoenix logs. So this is how I do it, and you can see that I need to call this command python m, that is for module, and I call phoenix.server.main, and I ask it to serve, and all the output is piped to the Phoenix logs under .phoenix folder inside your local inside your home folder in Linux. So all these things are happening after we do this. Okay, so once we do that, as I told, we need to use this python m phoenix server main.serve, and after we have all done this, you can actually connect at HTTP localhost 6006 port. So this is happening by default. Now if I go back to my shell, and if I clear it, and if I do a PSA, you will see that I have a couple of servers already running. So I have Jupyter Lab already running, and I have Python running. So the Phoenix server runs as Python. Okay, if you look at your process, it is simply called as Python. It does not have the name Phoenix. And also you can see that I have the telemet env here. So what it means is, before I do a pip install arise Phoenix, right, I actually create a separate virtual environment in Python. Out there are lots of discussion on how to create virtual environments. Even in my own channels, I have discussed about this. Use a simple virtual environment tool to create it, and then install all of these things inside the virtual environment. In my case, it is Telemetry environment, and I've already activated it. Right, and once you do that, so now I'm going to kill the server. So I'm going to kill the Phoenix server, which is running in process 47s. And once I kill it and once I execute, you will see that it has been killed, and it actually tells which command related process was killed. So now you can see that the Phoenix server that I was already running is gone. So now I call the Phoenix alias, and once I execute it, what will happen is the new process has been started. So if I do a PSA again, so you'll see that the 15817 is the new process ID for the Phoenix server. So how I know this and what's happening? So I will show you at the background right now. So if I go into the Phoenix folder, which is by default created by the Phoenix server, so that is a folder where all the configurations are present, I have actually got the logs running. So when I start the server, you'll see that the logs are getting written. So it will start running the migrations, and it will start looking for the web database, and it will start up the server on 0.0.0.0 meaning you can actually run it on a remote server, and you can still connect to it using the remote server IP. So in my case, it's running in local environment. And once I click on that link, you will see that I have this server here. So this is the Phoenix server that I was talking about, and if I click on any of the projects, you can see the various traces that I have already logged to it, or stored into it, and these traces has all the information. Now before we dive into this, I want to go to the next step. So I will actually show you the parts of traces in a couple of seconds. Before that, I want to dive into the process of instrumenting the server. So after we get the server up and running, after we connect to it, the next thing is we need to instrument the DSPY and OpenAI onto Phoenix. So that's what we are going to do next. So let's go back to the Jupyter Notebook, and this Jupyter Notebook code will be shared with you guys. So you don't need to worry about it. It's already there in the repo called as code.ai_fusion. So this particular repo links are there in the description. First foremost, we need to get the OpenAI API keys into the environmental variable of this notebook. So I used .env for that. So this is the first cell that I'm executing, and next comes the instrumentation part. As just for a second, visualize. So you guys know that there is a DSPY Python package, so that you can install it using pip installation. Also, you know that there is an OpenAI package that you can again install using pip installation, right? These are all separate packages that has been written by different teams and organizations. But now, how will I go into these packages and try to get various information about how these packages are working? Meaning, how to get the information about when a particular request is, what is the input, when a particular request is sent, and what is the output that particular request is getting. So how will I get all this information? So for that purpose, there is already an existing resource under OpenTelemetry where other teams are actually writing the instrumentation packages. So there are separate instrumentation packages that go and write the instrumentation points or instrumentation code into DSPY and OpenAI. You don't need to do it by yourself. You don't need to manually do this. So it's already done for you. And after that is being done, we can use these imports to actually get the tracing started. So you need to install the OpenAI, so OpenTelemetry for DSPY. So if you go into OpenTelemetry and if you go into the ecosystem, you will see that it has got a lot of information, and it has got the details of the integrations, and you can go into the libraries that has been already using these things. This is one way. And another way is you can go to Open Inference, and in Open Inference it talks about the various AI related applications that has been for which the instrumentation has been written. So you can see that here almost all of the packages that work with the AI inferencing has been already instrumented. So all you need to do is go into DSPY in this case, and once you click on it, it will tell you how to actually do the installation process, and then it also gives you an example on how to do that, and you can actually start working from there. So this example is part of that. But there is one key aspect that I want to highlight. In these examples, if you look, so these examples actually talk to you about creating the just a second. Yeah, here you can see that this environment is talking about running the Phoenix server on your local machine, and then connecting to it using localhost 6006. But there will be other tutorials where they ask you to run the server through Phoenix server through your notebook. So this particular link actually tells you how to do it through command line. So it's also one of the reasons why I followed the command line option. Let's go back. And once you are here, you can see that we can actually import the DSPO instrumenter and various supporting parts like the trace API. You can import the OTLP exporter, you can import the SDK, and also you can work on the processors and the resources. One point I wanted to highlight here is that when you are going to work with a particular project, it's always better to use the project names specifically, and I am using the project name here as instrumenting DSPY. So you can learn more about working with the DSPY projects in this trace a deployed app link. So you can take a look at that, you will get more information. Once your traces endpoints are up and running, you will get such an output, meaning that your notebook is connected with this particular server. So you will get this request response back, and then you can actually run these to actually start the exporter, start the trace provider. You can then set the span processor, trace provider. All these things has to be set, and then only you have to run this DSPO instrumental.instrument. So once you run this method DSPO instrumental.instrument, your DSPY package will get all the necessary instrumentation set up internally. So you don't need to do this manually. After that, excuse me. So we are discussing about how to connect and instrument the DSPY. After that, we are going to call. So right now, both OpenAI as well as the DSPY backends have been completely instrumented, and we are going to call the OpenAI class. We are going to call the GPT-4o mini model, and we are going to give the OpenAI API key with max tokens of 2000. And then let's actually look at whether the tracing is happening. So let's go back. I'm going to change a couple of things here. So I'm going to keep the project name as instrumenting DSPY, which is going to be kept same, and I'm going to see to update this particular request to the OpenAI and see how this is going to change. So who is the top player in FIFA? It's just a random call, a random question that I am going to send, and the request to the OpenAI API has been completed with request OK, and also it actually gives me a completion here. Now if we go back to the server, and if you go to the projects, you will see that inside the instrumenting DSPY project, I have two traces. Initially it was one trace, now it is two trace, and you can see the input here. So I'm zooming in a bit, so you can see the input or the sentence completion that I started, that is who is the top player in FIFA. This is what I presented, and this is the output. This is a complete output that has been sent by the API. You can close this, and you can see all the steps. You can look at the tokens also. It gives a complete response from the from the API, and you can actually look at the status also. It's okay, and it gives you the latency of 2.74 seconds and what time. And the important point is you can add this to the data set. You can click on this and you can add this to a data set that you already have inside the environment. You can actually annotate the example. You can click on annotation. You can say test create, and you can give the labels, and you can score it also, and say I give a label as good, excellent, yeah, there is nothing wrong about it, and I say 0.95, and if you want you can give the explanation here, and if you save this, and this will actually get updated to the span. So what does this mean? So if you go back, you'll see that here there is an additional information under the feedback. So like this, you can actually look at the complete trace. You see, it's not just a single data point. It has got a lot of information from the model, from the input, from the output process, to annotating it, to looking at the time, date, the feedback. It has a huge amount of information, right? So this is what I call it as, perfect visibility or observability of a particular application. And this is made possible because of the Arise Phoenix collector, and also the OTLP protocol that has been developed and updated using the OpenTelemetry standards. OpenTelemetry standard is part of the cloud native protocols. It's actually open source application by itself. This was developed in a long time back. It's not a recent development, but Open Inference is a recent development after the various AI models started coming into picture. That's when it got developed. So now we have seen the entire process. We have seen how the instrumentation and collecting works. We have seen how to set up the Phoenix server locally from your command line. We saw the background of the OTLP protocol and the framework. We saw the telemetry parts. What are the parts of the telemetry, like traces, logs, spans, metrics, and baggage. And the reason why we actually chose Phoenix to begin with, that is the development of metrics to simply discover. So that's where I started researching about these topics. So I believe that you have got some good information on how to trace your deployed app, and also how to trace doing your development also. So if you do like this content, leave a like, share it with others, and most importantly, subscribe to my channel for getting further updates on this series of videos. The point here I want to make again is that this particular idea of storing whatever you are developing, and the metrics as well as the traces is very, very important. So I believe that you will be using Phoenix as well as the supporting ecosystems of OpenTelemetry for your betterment. With that said, have a great time. Keep practicing.